Good morning, Honors Pre-Calc. This is the second video in our Polar series, Unit 4, Topic 3. When we finish this lesson, you should be able to do Homework A, listed in the newest module posted. I know that it says Unit 4, Topic 2, but we already know that we are on Topic 3. And the only homework I want you to do at this point is the Homework A. There should also be a Homework A in the assignment portion of my MCPS where you could submit this homework. If you remember, I handed out 2 packets and a progress check review. This is the Polar packet, so if you have that packet, you can follow along and take notes on page 5. If you do not have that packet, you can go on to my MCPS and the Google Drive link, and you can get a copy of the packet there under Unit 4, Topic 3. When Ms. Patel did her video, she reviewed these equations with you that I just want to emphasize one more time because we'll be using these in my lesson today, which is converting between rectangular coordinates and polar, and then vice versa from polar to rectangular. In doing so, you will need the following formulas. You will need the horizontal component, x equals radius times cosine theta. Y, or the vertical component, which is radius sine theta. You need the equation that ties x and y together, r squared equals x squared plus y squared, otherwise known as Pythagorean, otherwise known as the equation of a circle. However you look at it, you can use it to go between r and x squared and y squared, meaning you can go, helps you convert between rectangular and polar. And lastly, we have tan theta equals y over x. If you think about how we used it in the past, we have used the inverse tan and that ratio to find an angle. So I'm going to do first polar to rectangular in example 4. I'm going to do 1 in radians and 1 in degrees. For our first example, B, I'm going to draw the polar coordinates here. If it's -4, that means there are 4 rings around the origin. And when you are graphing these, you're always going to be starting with the angle. That angle is going to be in quadrant 4, negative pi over 4. But this negative sign here tells you to go 180 degrees in the opposite direction 4 circles in. So from the origin, going in the opposite direction, 1, 2, 3, 4. That means the point they gave you is right there in the second quadrant. Now that helps you because when you create your x and y coordinates, you should expect that also to be in the second quadrant. So using the formulas above, we're going to start with x. X equals r cosine theta. So x equals the -4 from the polar equation, and then cosine of negative pi over 4. X equals -4 cosine of negative pi over 4 from the unit circle tells you that it's going to be multiplied by square root of 2 over 2 and then simplified. X equals -2 rad 2. And again, since this is a negative x value, it's going to be somewhere either in the second and third quadrant, but of course we know it's going to be in the second quadrant because that's where our polar started. To do the y coordinate, same thing. Y equals r sine theta. Y equals -4 sine of negative pi over 4. And this time, because it's sine, it's going to be -4 negative square root of 2 over 2. Simplified is -2 rad. I'm sorry, it's positive. Negative times negative is positive. +2 rad 2. So the answer to B as an xy coordinate is going to be negative 2 rad 2, 2 rad 2, x, y. Going down to letter F. I don't even need to draw this because this is in degrees, and because this is not one of the special angles from our unit circle, we don't even have to worry about really, this is a calculator problem because this is not one of the angles from one of our special triangles in the unit circle. So x is going to be r cosine theta. X is going to be 7.5, and then cosine of 110 in our calculator. X is going to be negative 2.56, and then rounded to 5. Our y for F is going to be r sine theta. Y equals 7.5. Sine of the same angle, 110. Using our calculator, that value is going to be 7.04 rounded to 8. And so then our coordinate in xy, or rectangular or Cartesian, is going to be negative 2.565, comma 7.048. Sorry for the sloppy handwriting. Going down to example 5. Now we are creating polar coordinates, and we are not using a calculator because we are not doing B. So first of all, what we're going to do is we're going to see where this point is going to be. It's negative 1, 1 over here. So once again, we are in quadrant 2. Okay, we need an r and a theta because remember, polar coordinates look like this. The easiest equation to find r using x and y is x squared plus y squared equals r squared. So we've got negative 1 squared plus 1 squared equals r squared. So r squared equals 2, and r equals radical 2. Plus and minus. Now remember, there are an infinite number of ways of writing polar coordinates. This is asking for 2 different ways. So we're going to do one with a positive square root of 2 and one with a negative square root of 2. But before we do that, we need the angle. I'm going to do tan theta equals y over x. So it's going to be 1 over negative 1. If I want the angle, I'm going to do inverse tan of negative 1, which is going to give me negative pi over 4. Remember, tan is negative in the, it's negative from negative pi over 2 to pi over 2. So our calculator is going to give us within that domain. But remember, since we are doing 2 different points, if r negative pi over 4 is in the 4th quadrant, remember we go 180 degrees this way, so we need the angle here. We know this reference angle is pi over 4, so that means this angle here is 3 pi over 4. So now we have enough thetas and enough radii in order to do 2 polar coordinates. One is going to be positive square root of 2, and then since this angle 3 pi over 4 is also in the 2nd quadrant, 3 pi over 4 is going to be the matching theta. Another point is going to be negative square root of 2, and from doing our inverse tan, we saw that its matching theta is negative pi over 4. Our last example, letter C, is a little unusual, and I am going to draw the coordinates first so you can see how different this is. So first of all, it's 5, 0, which is over here. And so obviously this is going to be one of our quadrantals. And again, we're not going to use a calculator for it. So first, let's start with the easy stuff. Finding r squared. R squared equals x squared plus y squared. You can think about it as a magnitude because r equals the square root of x squared plus y squared. If I get r by itself, r equals the square root of 5 squared plus 0 squared, r equals 5. Now I need to find my theta. I don't need to do inverse tan here because I already know over here that this angle is 0, and you can do it as pi. I think I'll do it this way rather than in degrees. And then we need 2 polar coordinates. So I need this over here, which is exactly in the opposite direction. So this angle over here is going to be pi. And what did I forget here for my radius? What I forgot is that it's plus and minus. When you are doing these radii, plus minus, you're always going to get 2 different values. For our coordinates in polar form, I'm going to have 5 with 0 pi. And I'm going to have -5 with pi. Okay, I hope you enjoyed that formula. Remember that, or this lesson. Remember that your homework is going to be homework A that is now posted on my MCPS. Thank you.